This is example 12 with trig identities. So if you want to copy this packet we've been using for these videos, check the video description here. There's a link. You can click that link, open up this packet, print it out, and follow along if you'd like. So look at this. Sine squared of theta minus 1, all divided by tangent of theta sine of theta minus tangent of theta equals sine of theta plus 1 over tangent of theta. So we want to establish this identity. Terrible, terrible, what a mess. It's actually not going to be that bad though, which is nice. So if we go back to our steps here, our general process from an earlier video, always start on one side, try to make it look like the other side, and apart from that, some things to try here. So start with the more complicated side is what we usually want to do. And in this case, I think the left side is a little more complicated. So we have a quotient on both sides, but here we have subtraction, subtraction, multiplication. Here we just have addition on top. That's not too bad. So the left side's a little more complicated, so we're going to start there. Okay, so sine squared of theta minus 1, all divided by tangent of theta, sine of theta, minus tangent of theta. Okay, so where can we go? All right, we want a tangent of theta on the bottom, and we want a sine theta plus 1 on top. Okay, so here we have a sine squared of theta and then a minus 1, so you might think, okay, well, can we use Pythagorean identities at all? And it might look like we can, it's tempting to try it, but it's actually not going to help us. Why not? Well, here, sine squared of theta plus cosine squared of theta is 1. You can subtract 1 from both sides and subtract cosine squared from both sides. So then you'd end up with sine squared of theta minus 1 equals negative cosine squared of theta. And you can toss that in here, but it's really not going to get you anywhere. You know, it's not really bad to try that at first. You know, try whatever you can think of as long as it's legal to do it. And that's a totally legal thing to do. We can try that, but it's not going to get us anywhere, so let's not go through it in the video. But what we can say is okay, I want a tangent just by itself on the bottom. Well, I kind of have a tangent here, but what do I notice? I notice that tangent of theta appears in this term, and tangent of theta appears here by itself. So that's really like tangent of theta and then times 1, right, like that. So let's factor the bottom. Okay, factoring is not really something we have tried yet for any example we've done, but one of the steps to try is factor. This factoring can reveal identities that were hidden and can lead to reducing quotients. So tangent of theta appears in both terms on the bottom, so let's factor that guy out. So tangent of theta times the quantity, what's left, sine of theta, and then minus 1. Okay. Well, hey, that's great. So here's a tangent of theta. Now, if we could somehow get rid of this guy, then we're in business, right? Because we'll have tangent by itself, and hopefully the top will work out too. We'll see what happens. Well, here, sine squared of theta minus 1, what is that? That's actually, it's a difference of squares, right? So remember, if we have something like a squared minus b squared, how do we factor that? That's just a minus b times a plus b, right? Okay, or a little more similar to our case, what if we have x squared minus 1? So here we have sine squared of theta minus 1. So remember, 1 is the same thing as 1 squared, so it's really a difference of squares, because 1 is the same thing as 1 squared. Okay, so so this is x squared minus 1 squared, so we can use the same thing. So it's x minus 1 times x plus 1. Okay. So here we don't have x, we have sine of theta. Okay, but what changes? Absolutely nothing changes. So sine squared of theta minus 1, that's the same thing as sine of theta minus 1. Okay, times sine of theta plus 1. Really squishing that in here. What a mess. Okay, but anyway, my point is it's a difference of squares, because remember, 1 is the same thing as 1 squared, so we can just use this property here. Okay, so even though it's sine of theta and not x, the exact same rule applies. Okay, we can factor it exactly the same way. So sine squared of theta minus 1 is the same thing as sine of theta minus 1 times quantity sine of theta plus 1. Okay, because we know from pre-calculus or algebra, whatever, x squared minus 1, we can factor that in a x minus 1 times x plus 1, right? Well, even though it's sine of theta, not x, it's exactly the same thing. It's a little more complicated to write, more complicated expression, but it's a difference of squares. It's something squared minus something else squared. So we can factor it using this general rule here. Okay. So sine squared of theta minus 1, that is sine of theta minus 1 times sine of theta plus 1. Okay. It's so a squared minus b squared becomes a minus b times a plus b. So what do we have? Sine of theta minus 1 on top, sine of theta minus 1 on the bottom. Cancel, cancel, and we're left with sine of theta plus 1 on the top, and on the bottom is just tangent of theta. is that what we wanted? Yes, that's exactly what we wanted. That's great. Okay, so that's it for example 12. So notice this actually wasn't really that complicated. It looks really nasty, really terrible, really complicated. But the only thing here was just try factoring, right? So again, how do we know to try factoring? Well, we don't really, maybe we don't know that right away, but it's one of our things here to try. Okay, so you might also be tempted to try the Pythagorean identities because of the sine squared, and you can try that, but it won't get you anywhere. Okay, it'll be kind of a mess. But if you try that, it doesn't work, just try something else. And eventually you'll end up trying factoring, and you can look at this and say, okay, well, I want a tangent of theta by itself on the bottom. I have it in both terms on the bottom, so let me factor it out, see what happens. Well, then I'm left with tangent of theta times sine of theta minus 1, okay, and I have that on the bottom. On the top, I just want sine of theta plus 1. Well, what I have on the top is, on the top I want a sine of theta plus 1, but what I have on the top is sine squared of theta minus 1. Well, hey, 1 is the same thing as 1 squared, so this kind of sort of looks like a difference of squares. Well, it is a difference of squares, right? It's just something squared minus something squared. So I can use that property of factoring differences of squares. Even though it's sine of theta and not just like x or a or just a number or whatever, we can still use this property, okay? There's absolutely no reason that we can't. Okay, so when we use it, we just get, so a squared minus b squared is a minus b times a plus b. So now on the top we have sine of theta minus 1, on the bottom sine of theta minus 1, they cancel, and we're left with exactly what we want. That's great. Okay. So this is a good example of a trig identity that looks really bad, really complicated, but actually isn't that bad. So the trick here is just remember to try to factor. Okay, so it's one thing that you'll want to keep in mind, and it's one of our steps here. So that's it for example 12. Example 13 coming up next.